We'll be starting Unit 4, which is all over probabilities. And in this video, we'll be covering Chapter 11, Section 1, the Fundamental Counting Principle. The fundamental counting principle is if you choose one item from a group of M items and a second one from another group of N items, then the total number of choices that you have is going to be those two numbers multiplied together. For example, brown or black pants, and you can choose a red shirt, a white shirt, or a blue shirt. How many different combinations are there? So what we use is what we call a tree diagram here. Our first choice is what color pants we want. We could choose the brown ones or we can choose the black ones. And then with each of these choices, we can pick a red, white, or blue shirt. So here I have red, white, and blue. So I can have brown pants with a red shirt, brown pants with white shirt, brown pants with a blue shirt, or black with red, black with white, and black with blue. Here you can see that we have a total of 6 choices. What we could have done was just say, well, we have 2 options for the pants, 3 options for the shirts. That makes a total of 6 different combinations we could have. Let's look at some examples. Example 1 says a restaurant offers 10 appetizers, 15 main courses. How many ways can you order the 2-course meal? Well, if we have 10 appetizers and 15 main courses, we could have a total of 150 combinations. Example 2. There are 10 math classes to choose from and 4 sciences that are available at times that do not conflict with each other. How many ways can you create a 2-course schedule? 10 math, 4 science means that we can create 40 different schedules. Example 3 says a pizza can be ordered with 2 choices of size, either medium or large, 3 choices of crust, either thin, pan, or hand-tossed, and 5 choices of toppings, beef, sausage, pepperoni, bacon, or mushrooms. How many different 1-topping pizzas can be ordered? So notice here we have 3 different options. We're just going to expand on the fundamental counting principle and say, well, if we have 3 options, we're just going to multiply those numbers together. So there's 2 sizes, 3 crust, and 5 toppings. If I multiply all this together, there's a total of 30 different 1-topping pizzas that can be ordered. Example 4 says, suppose that you order a car. How many possible ways can this car be ordered with the given options? So for colors, there's 10 different colors. You can have AC or no AC. It could be an electric car or a gas car. It could have an onboard computer or no computer. It could also have a GPS or no GPS. So there's 10 colors, 2 choices of whether you want an AC or not, 2 types of cars, electric or gas. Either you want a computer or don't want a computer. And then you can either have a GPS system or not a GPS system. So all we're doing here is multiplying all of the choices together, and we can find out that there's 160 different choices on ordering a car. Example 5. You are taking a multiple choice test that has 6 questions. Each question has 3 answer choices. If you select one of these choices, leaving nothing blank, how many ways can you answer the questions? And on this one, it's really important that it says it leaves nothing blank, because leaving a question blank would be a 4th option. You can answer A, B, or C, or none at all. So here it says you leave nothing blank. That means you have to choose one of the 3 answer choices. The way I wrote it down here is I have question 1, question 2, question 3, question 4, question 5, and question 6. Remember, there are 3 possible answer choices. So I'm going to have 3 choices to answer question 1, 3 choices for question 2, and so forth. This is going to be the same thing as 3 to the 6th power. That is going to be equal to 729 possible combinations. Problem 6. A 5-digit code can open a gate. The keypad has the options of these 10 numbers. 1 through 9 plus the 0 makes 10. How many different sequences are possible if 0 cannot be used in the first digit and all the other numbers can be repeated? So in this particular case, for the first option, you only have 9 choices because you cannot use a 0. So we have 9. The second option, we have 10 choices because we can choose a 0 or the numbers 1 through 9. For the third option, since the numbers can be repeated, we would have 10 options for the third digit. 10 options for digit 4 and 10 for digit 5. So our total number of possible combinations would be 90,000. One of the first things you want to do when practicing the fundamental counting principles is utilize the MyMathLab tools that you have available. First thing you want to do when you're in your class is go to the MyMathLab tab. You will see 5 different options, and you're going to go to the 4th one, the MyMathLab Multimedia Library. When you click on this, you're going to select Chapter 11 and Section 1. Select all and press Find. This will give you a bunch of tools that you have available. It will give you your PowerPoint. It will also have additional videos here. And the part that I like the most is the animation section. Now here you have 2 different ones. The first one is combining counting methods. We actually have not covered this part yet, but it will be a good tool in the future. Let's go ahead and go to the second option, the fundamental counting principle, the tree diagram. What we're going to do here is read the problem, solve it on paper, and then hit the start animation to see if we have the correct answer. So it says there are 3 things that can happen. So the first thing I'm going to do is go ahead and start off with 3 blanks. The first can happen in one of 7 ways. So we have 7 options. The second thing can happen in 4 ways. So for the second thing, we have 4 options. And then for the third thing, we have 3 options. So all we're going to do here is use our calculator to see what that comes out to. Here we have 7 times 4 times 3. We have 84 possible combinations for this question. So I'm going to go ahead and start the animation and let's see what happens. Okay, it says there are 84 different ways for these 3 things to happen. That's exactly the number that we got here. So I'm going to go ahead and reset and try another one. There are 3 things that can happen. 1, 2, and 3. The first thing can happen in one of 3 ways. The second can happen in one of 5 ways. And the third thing can happen in one of 3 ways. How many different ways can these things happen? Well, let's go ahead and do this one. 3 times 5 times 3 is going to come out to 45. So there will be 45 different ways that these 3 things can happen. Let's start our animation. Okay, there it goes. There are 45 different ways that these 3 things can happen. That's exactly what we got on our paper. Alright, this is another great tool for you guys. I highly encourage for you to practice using these animations. This concludes 11.1. Let me know if you have any questions.